Level 1. The kid who rewired everything. You are 9 years old, taking the motor out of a broken RC car and wiring it into a fan you built from cardboard and popsicle sticks. More interested in what the motor could become than what it was originally for. Your parents stop buying you toys that work properly and start buying you toys that are interesting to break. Having learned the difference matters enormously to you, filling an entire closet shelf with parts salvaged from things that used to work fine. You win your first robotics competition at 11 with a robot made almost entirely of Lego and one stolen servo motor from your sister's science kit, a theft she still brings up at family dinners, though she quietly asks to see the robot every time you visit. You build a robotic arm out of popsicle sticks and fishing line that can pick up a grape without crushing it, a small triumph of tension and calibration that takes you 11 attempts and one minor crying fit to get right. A moment your father captures on video that resurfaces at every birthday since. Level 2. The Kit Basher. You are 17, deep into your first serious build outside of school competitions. A hexapod robot assembled from a kit you've modified so heavily it barely resembles the original instructions anymore. You fry your first motor driver board with a wiring mistake so basic your robotics teacher can't help laughing. A lesson about reading data sheets you never forget again, one that costs you 3 weeks of saved allowance to replace. You spend your entire senior year building an autonomous, line-following robot for a national competition, rewriting the control code 4 separate times as you actually understand feedback loops for the first time instead of just copying examples you found online. You place 9th out of 60 teams, a result that stings for exactly 1 day before you're already sketching improvements for next year on the back of a napkin, already certain 9th place is temporary. Level 3. The Debugger at 3 a.m. You are 22, hired as a junior robotics engineer at a small industrial automation startup, discovering within your first month that the job is 90% debugging and 10% the exciting robot building you actually studied for. Your first real crisis hits during a client demo when a pick-and-place arm starts moving in a pattern nobody programmed, and you spend the demo pretending this is intentional while frantically diagnosing a sensor calibration error in your head. You develop a specific relationship with 3 a.m., the hour you're most often awake chasing a bug that only appears under load, staring at oscilloscope traces until patterns start meaning something. A senior engineer finds you asleep on your keyboard one morning mid-fix, and instead of sending you home, quietly brings you coffee and helps you finish, teaching you that this job runs on people covering for each other's exhaustion, a lesson you start quietly passing along yourself within the year. Level 4. The Actuator Whisperer. You are 28, known now on your team as the person who can diagnose a mechanical problem by sound alone, a skill you didn't realize you developed until a colleague asked how you knew a bearing was failing before any sensor flagged it. You lead the mechanical design on your first full robotic system, a warehouse-picking robot that has to survive 24-hour operation without a single unplanned stop. Your prototype fails catastrophically during stress testing, an actuator seizing under repeated load in a way your simulations never predicted, sending you back to redesign a joint you were completely confident in 3 weeks earlier, questioning every other assumption in the design along with it. The redesigned version runs 11,000 cycles without failure, a number you check obsessively for days afterward, unable to fully trust a success that big without checking it several more times, running the numbers again at midnight just to be sure. Level 5. The Integration Lead. You are 34, running integration for an entire robotic system now, responsible for the moment where mechanical, electrical, and software teams stop being 3 separate groups and become one working machine that actually has to function together. You learn that integration problems are almost never technical. They're miscommunications between teams who each assumed the other handled something nobody actually owned, a gap that only ever becomes visible once it's too late. Your first full system launch fails in front of the client because a firmware update 3 weeks earlier silently changed a timing assumption the mechanical team never knew about. And you spend the entire client visit troubleshooting live while maintaining a composure you don't actually feel. You fix it in 90 minutes, hands steady even as your mind races through every possible failure point. The client never learns how close it came to falling apart entirely, and you decide, driving home afterward, that some things are better left unsaid. Level 6. The one who signs the safety sheet. You are 42, the person whose signature now certifies that a robotic system is safe to operate around actual human beings, a responsibility that changes how you sleep the night before every major deployment. You reject a design 3 separate times from a team under serious deadline pressure, refusing to sign off on a safety margin you consider inadequate, absorbing frustration from people who don't yet understand you're protecting them too, a frustration that occasionally follows you into the parking lot. A robot you approve malfunctions on a factory floor 8 months after deployment, and though the safety systems function exactly as designed and nobody is hurt, you spend that entire night reviewing reviewing every calculation you made, finding nothing wrong and feeling no better for it. You understand now that this job is as much about carrying weight as it is about building machines. A weight nobody warns you about in engineering school. Level 7, the architect behind the curtain. You are 59, a principal engineer now, spending most of your time reviewing designs rather than building them. Your name attached to systems used in factories you'll never personally visit across a dozen countries. You mentor engineers who have no idea you once cried over a grape-lifting robotic arm made of popsicle sticks, though you tell that story often, specifically because it still matters. You visit a middle school robotics club on a Saturday and find a 9-year-old wiring a broken toy motor into something that isn't quite working yet, brow furrowed with the exact same focus you remember from your own garage decades ago. You crouch beside her and ask what she's building. She says she doesn't know yet, but it's going to move. You tell her, honestly, that not knowing yet is the best part and that you still don't always know either, watching her go right back to work without waiting for a better answer.